CU Science Update. Hurricanes. CU researchers chase after these mega storms. Barn swallows. Students find out that it's the feathers that make the man. Next on CU Science Update.
Hurricanes are defined as severe tropical storms that form in the southern Atlantic, the Caribbean, the Gulf of Mexico, and the eastern Pacific. These violent cyclonic storms gather heat and energy through contact with warm ocean waters. Here at CU Boulder, faculty and students at the Department for Atmospheric and Oceanic Sciences are in the midst of whirlwind research to understand the characteristics of these storms. Maria Hanau-Ohms tracked down a CU storm chaser to file this report.
With over $15 million in damages, Hurricane Gustav was the fourth costliest storm in the 2008 hurricane season. And although hurricanes have been studied for many years, there is still a lot of information to be gathered. Dr. Katja Friedrich is a faculty member in the Department of Atmospheric and Oceanic Research, or ATOC, at the University of Colorado Boulder. She recently led a research team into Hurricane Gustav. The goal of the trip was to gather information about the size and intensity of the storm.
A radar image from the Houston radar, and the three dots are actually the location where we were deployed. So one is the radar and two are the pickup trucks. And the yellow, greenish, bluish colors are actually radar reflectivity. It tells you something about the precipitating particles. So here you see nicely how Hurricane Ike were moving towards or made landfall at the coast of the Galveston Island. So here we are in the center of the hurricane in the eye, and here you have these outer rain bands.
Dr. Friedrich's initial research focus was always precipitation, but severe weather caught her attention immediately.
I always looked at precipitation, all kinds of precipitation, thunderstorms, orographic precipitation, winter storms. But it was not really severe or very traumatic events. I mean, sometimes there were some flash floods, but generally it was very mellow precipitation. And then when I came here to the United States and I started as a professor here at CU in January this year, I got involved in all these activities with storm chasing or hurricane chasing. And that drew a completely different perspective on what I have been doing before that. I think this season was not really outstanding. I think there were three major hurricanes that made landfall in the United States. The reason why it made it so special for me was actually that I got involved in taking all these measurements. So generally I take measurements of drop sizes. I'm really interested in processes that enhance or form precipitation. So the next hurricane just came like two weeks after Gustav. And so I took the chance, I took some days off and we drove down there and we took the measurements. And that was very exciting for me because hurricanes are very destructive, and you can see that the water's rising when buildings catch fire. But what was very interesting for me to have the measurements, to know exactly at what point within the hurricanes we are located and compare it to the measurements. And also seeing the strength of the surge, seeing the strength of the wind and compare it with the measurements. That was, for me as a meteorologist, an incredible experience because I teach about hurricanes and know it from theory. I look at radar, satellite pictures, I look at radar pictures, but really, being inside is a completely different story. 20 hours ahead of the landfall, then we had to start to deploy our instruments. The difficulty is usually that people get evacuated, so you're driving against the flow, and then you have to set up these instruments. A lot of people get also very interested in looking at the coastline, what's going on, the waves and so on. So we started about 10 to 15 hours before landfall, we started to deploy these instruments which measure wind, precipitation, and wind velocity, wind direction, and pressure. And so we deployed them along the coastline. We put them on very solid platforms, and then usually we put sand sacks or concrete just to make it very stable so they don't tip over. The other good thing is that they're not very high, so they don't get picked up very easily by the wind. And after we deployed these instruments, we had to deploy the radar and also our pickup trucks. With the truck, we were usually putting the nose into the wind, and we had like winds 70 to 100 miles per hour, and that is something, I mean, if you move the car into the wind, this is something, I mean, you can easily stand, or the car does not flip over or tip over. So it's actually pretty tough on your nerves because you're sitting there in the car for, I think in the total we said 18 hours with my students and sitting in the car windy, and it was a lot of precipitation. So,
when not in use, a few of the instruments used during the research trip are currently housed on the roof of the Duane Physics Building.